Okay guys, here this next video is going to be a little bit more tricky because it covers exponential and logarithmic equations. And we kind of mapped out this flow chart in class. I erased it, and of course it wasn't as detailed as this. So I went ahead and made this. I'm going to try to scan it and post it for you on Blackboard, but I wanted to see it here. So you could always stop the video right now and write it down, or see if you can make sense of it and have it off to the side. So this is your flow chart, and I'll kind of zoom in. Do you have a log or exponential equation is the question. And so if you say you have an exponential equation, that means your variable is trapped in the exponent. And the first question you should ask yourself is, can you make the bases the same? If you say yes, well then you're expected to do that, or at least attempt that. If you don't know how, then you can always go to the next part. So I did write a little example of, well, what does it look like to make the bases the same? And I solved that problem. So if you say yes, make the bases the same and set the exponents equal to each other. So if the bases are the same, you can set the exponents equal to each other. If you say no, well then you need to, if you can't make the bases the same, rewrite in log form. So here's an example of that. If you still say no and you can't rewrite it in log because you have a variable trapped in both of the exponents, then you need to take the log of both sides. But we didn't really explore this too much in this class, so I think that's okay if I don't have an example of that. Now, if you come over here and you say you have a log equation, that means your variable is trapped inside of a log. The first question you should ask yourself is, do you have multiple logs on one side of the equation? Of course, that's a yes or no question. If you say no, you are expected to condense using your laws of logs, and write it down using, condense it to have only one log using the law of logs. So here's an example. Addition really meant multiplication. Subtraction really meant division. And so I show you a quick example of how to condense. If you say no, then you have to ask yourself, well, do I have a log equal to a log already? And if that's the case, then you just set the insides to solve. If you say no, you are expected to rewrite in exponential form. So let's go ahead and get started. I have a problem written already over here. And so we're gonna zoom in, kind of magnify on problem number 11 from the review. So it does say solve, round if you need to. So let's get started. Let's look at 11. First thing we want to do is identify is a log equation or is an exponential equation. And then we have to utilize that flow chart. So hopefully you wrote it down or took a screenshot, and you can kind of refer back to it. So in this case, you said it was a log equation. And so the choices were, do you have multiple logs? Do you have a log equal to another log? So in this case, we don't have multiple logs to condense. We don't have a log on the other side. So we can't just set the insides equal to each other. So by default, we have to rewrite in exponential form. We just got finished practicing that in the last video, so this should be a piece of cake. So we're gonna rewrite in exponential form. So that would be 9 to the third power equals x. And it basically solves itself once you rewrite it. So you do need to figure out what 9 to the third power is. 9 to the third power is 729. So we get 729 equals x, and that's your answer. Of course, you can check this by plugging it in right here and putting this part in your calculator, and of course you'll get 3. Let's move on to the problem 12. Hopefully you're noticing the same setup. We have only one log on one side. So whenever that happens, you need to rewrite an exponential. So we have 6 to the 5th power equals x minus 4. And so of course 6 to the 5th power is 7776 equals x minus 4. One step left to solve for x. Let me pull up that real quick for you. I just need to add 4 to both sides, and these are just numbers. So we get 7780 equals x. And that's all we had to do on that problem. So rewrite and move your 4 over to the other side and you're good to go. So while we're still here and these are going fairly quickly, let's take a look at 13. We're still camped out on solving logarithmic equations. This is just natural log, not to worry. But it does only have one, so that means I'm going to have to rewrite in exponential form. But you're thinking, what is my base? And hopefully you remember from the last video and the last set of problems, when you don't see anything right here, it's an implied base of an e. So if I'm going to rewrite in exponential form, that's e to the 0 power equals 2x minus 1. And anything to the 0 power is equal to 1. So that's 1 equals 2x minus 1. Now we're just solving a classic linear equation, so hopefully this is coming pretty easy to you now. So that's 2 equals 2x, divide both sides by 2, and we get x equals 1. Not too bad. Again, these are very intimidating looking because, you know, our eyes aren't used to solving logs and exponentials, but if you just slow it down, walk yourself through the flow chart, make sure you don't forget some fundamentals like anything to the 0 power is equivalent to the 1, or you can even put that in your calculator. I mean, don't shy away from using this. So you might be thinking, okay, but where's the E button? Remember, we looked a little bit about this. If you go to natural log, right above it in blue is the E. So you do have to hit the second so that you can access all of your blue buttons. And so you get this on your screen. Hopefully, I don't know how well you're gonna be able to see with the light. I didn't think about that part when I was doing this. You just put 0 and you hit enter and you get 1. So hopefully you'll be able to see that pretty clearly. Let's move on to problem 14. 14, here we go, there he is. Again, hopefully you remember from the last video, if you don't see anything here, it's an implied base 10. Again, same pattern that's happening in all these, so you better expect to see something similar to this on the test. It's only 1 log, so then we have to rewrite. So this is base 10 squared equals 3x plus 1. And so 10 squared is 100 equals 3x plus 1. We're going to subtract 1 from both sides. We get 99 equals 3x. Divide both sides by 3. I think I'm cutting it off. X equals 33. So this takes us through 11, 12, 13, and 14, and I'll pick up in the next video for the rest.